Welcome to the introduction and overview of APTI 419B, Preparation of Fine Particle Emission Inventories. This is the sixth of several modules that introduce the APTI Classroom Course 419B. This module introduces non-point sources. What will we cover in this module? Well, we'll define non-point sources and give examples. We'll also cover the basics of non-point emissions estimation and discuss tools to identify and inventory those sources. We'll discuss ways to prioritize inventory efforts, and we'll give a quick overview of uncertainty in the non-point source inventory. Non-point sources are usually small, ubiquitous sources that are not practical to inventory separately. The non-point inventory includes any stationary source emissions that are not in the point source inventory. They have a large impact on PM 2.5 air quality. Tools to develop the non-point inventory may be found on the EPA's chief website. Typical categories include open burning, which is a major source of organic and black carbon matter, fugitive dust, the major source of crustal matter, and external fuel combustion, which is a major source of organic carbon matter, a moderate source of black carbon, and a minor source of crustal matter. Examples of external combustion are small boilers, furnaces, and residential wood combustion. Let's talk a bit about the basics of emissions estimation. Each source type is assigned a source classification code so that similar sources can be compared and tracked together. Most emissions calculations are of the form activity data, Q, times the emissions factor, EF. This represents the uncontrolled emissions. These emissions can be reduced by a factor of 1 minus the control efficiency times factors representing effectiveness in penetration of the regulations. This relationship is shown in the general equation. The following tools can be used to identify non-point sources of PM 2.5. The EIIP Area Source Guidance, AP42, existing inventories, non-point category method abstracts, and receptor models. The Chief is EPA's website for inventories. It includes sections on emission factors, inventories, emissions modeling, and an emissions monitoring knowledge base. Triage is a term you usually hear associated with emergency medical care prioritization and/or prioritizing business decisions, but it also fits the process for identifying key source categories to emphasize in the inventory. Triage of sources involves asking these important questions for each non-point source category. What's the source's impact on air quality? What's its emissions reduction potential? Can the inventory be improved in the required time frame? And will improving this category make a difference? Let's talk a bit about uncertainty in the inventory. The emission inventory often is less accurate or precise than desired. Its accuracy and precision is affected by how well we can characterize activity data, emission factors, control efficiency, and the temporal and spatial distribution of emissions. Quantitative estimation of the emission inventory uncertainty is very difficult, but receptor models can help bound uncertainties. And also, there is a new grid modeling tool being tested that can be helpful. This tool facilitates comparison of chemically speciated model estimates with chemically speciated ambient data for the same time periods. This information can be used to ground truth the inventory. Let's summarize. Non-point sources are an important part of PM 2.5. Combustion and fugitive dust are the main broad categories. Many tools are available to identify these sources and estimate emissions. Prioritizing the effort is important. Non-point inventories are challenging, and uncertainty is often higher than desired. Quantifying this uncertainty is very difficult. There's more information contained in the classroom version. There's an expanded discussion of inventory development tools and emission estimation variables and methods. Thanks for your interest in non-point inventories.